Hi everyone, I wanted to make a video about Project 2. For those that were in class on Wednesday, we talked about it a little bit, but I did make some changes I wanted to let you know about. And if you weren't in class on Wednesday, I also wanted you to get this information as well. So here's the information you need to know about. So the first thing is in the instructions, on Wednesday I indicated that I only want you using Desmos for problem 1. And I've changed that. So now what I indicated is that you can use Desmos to find definite integrals when prompted. So you're going to have to take it on a question by question basis to figure out how I want you to calculate these definite integrals. Okay, and then again, just to remind you, you're not allowed to get tutoring or assistance from others on this project, and I don't want you using AI or any other websites like Symbolab, MathXL, or any other websites for assistance. So let's take a look at problem 1. You do need to know that there is some difference on problem 1. Previously, task 3 on problem 1, it wanted you to use the antiderivative to find the definite integral. But now I indicated that you can use Desmos to find the definite integral. Okay. If you weren't in class on Wednesday, I also showed everyone how to use Desmos to find the regression equations. So I just wanted to show you that real fast. You go to graphing to find the regression equations. You create a table, and you're going to, let me try that again, create a table, and you're going to need to create a table for the demand function and the supply function. So I'll go ahead and create 2 tables. The first table, we'll let that be the demand function. And what I mentioned in class on Wednesday is you have to be sure that your price is in the y axis. So the y values, I'm just going to enter 2, and then you can enter the rest. And then the x values will be the demand function. Again, I'm just entering in 2 of them. And same kind of deal with the supply function. The supply function, the price needs to be in the y, and the supply function needs to be in the x. It's just kind of a rule of thumb of economic data. Okay, and so now the nice thing about Desmos is they have this little icon that allows you to find regression equations. And in the direction it says that the demand curve needs to be exponential function. So you go and you find exponential regression, and it gives you the exponential function that you need to use. Okay. Of course, this isn't it because you're going to have to enter in all the data, but at least you know how to get it. Same kind of deal with the supply function. You click the icon. They want the supply function to be a quadratic regression. Okay, and so you can find that once you enter in all your data. Okay, but remember that that's going to help you to find the equilibrium price, where those 2 graphs meet. I think that you can zoom to fit that and see where those 2 functions intersect. And of course these don't intersect yet because I didn't enter in all the data. But where they do intersect, that's where you're going to go and find that equilibrium price. So then you can use that equilibrium price to find the consumer and producer surplus, and you're going to have to use integrals to do that. And eventually you're going to have to find definite integrals and use Desmos to find the definite integrals is allowed on problem 1. On problem 2, you're going to have to use our population function. Our population function, give me just a second here, I got some other noise happening in the other room. The population function is found, we talked about that in our class earlier. It's from, if you want to look at the online textbook, I'll look it up real fast while I'm on the video here. It's in chapter 6. Chapter 6, section 3, 6.3. It's page 350. Gives you the formula for the population based on the renewal function and the survival function. So a change with problem 2 is now we have the initial value of the population. We didn't have that Wednesday, so you might want to make note of that. And then you can use the formula for our population based on survival and renewal function that's in our textbook. And we also talked about it in the Desmos classroom activities as well. Okay. But in problem 2, I don't want you to use Desmos. I want you to find the definite integral using the antiderivative. Okay, so you have to actually find the antiderivative and then use the fundamental theorem of calculus. Fundamental theorem of calculus is that rule that says you can find the antiderivative and then plug in the upper bound into the antiderivative minus the lower bound plugged into the antiderivative, and that will give you the value of the definite integral. And then, of course, you have to interpret your results. Problem 3, we have a blood flow function, and now we need to find the... Now look at what the blood flow is. The blood flow is in milliliters per second, and I want you to find the total volume, and your total volume is going to be in milliliters. Okay, so I think there it's just going to be simply integrating our function. But then you're going to have to set up the definite integral of that function. Okay. Now to evaluate that definite integral, I'm going to want you to find the antiderivative of that. Don't use Desmos Classroom on numbers 2 or 3. You can use, please don't use Desmos to evaluate the definite integral on problem 2 or problem 3, but you are allowed to use Desmos to calculate the definite integral on problem 1. Let's take a look at problem 4. Here we have a differential equation. So for differential equations, I don't think that finding the definite integral on Desmos Classroom will be helpful at all. So you'll just have to solve the differential equation. When you solve the differential equation, be sure that you follow directions and solve the differential equation using separation of variables. If you don't solve by separation of variables, then that's not going to be the technique that I want you to use. So please solve the differential equation using separation of variables. Okay, so you then go to problem 5. Problem 5 is a normal distribution. I gave you the equation or the function for a normal distribution. That was in our Desmos Classroom activity. You can also find that in the online textbook, section 6.6. That's page 374. But also in the Desmos Classroom activity. They give you information on there. But here I say you can set up the definite integral and then use Desmos to calculate the definite integral. So you don't have to find the antiderivative there. You can just use Desmos to calculate that definite integral to find the probability. Same thing with task 2. And then you have to do task 3 using really a technique of your choice. Okay, so hopefully that gives you some sort of indication of the changes that I made to that. Pretty much the changes are that you are able to use Desmos to find definite integrals on problems 1, 4, and is that right? 4? Oh no, 4 is a differential equation. On problems really 1 and 5, if my memory serves me right. So, okay, if you weren't there on Wednesday, make sure that you upload a file for each question. Okay, so on question 1, please do your work and then upload a file that shows me your work only on problem 1. And then for problem 2, upload a file that only shows me your work on problem 2, and then problem 3, problem 4, and problem 5. So you're going to be uploading 5 different files that correspond to each one of those questions. Okay. Good luck on this, and remember that this is due on Wednesday, Wednesday the 13th at midnight, and so that means that we will be having a class between now and then. So, okay, I'll talk to you all soon. Bye.